So here we're asked to find all the derivatives of f of x equals x cubed plus 5x squared minus 5x plus 2. And you might be saying, well, what does she mean, all the derivatives? Well, when we take the derivative, when we find f prime of x, we actually call this the first derivative. And what we haven't talked to up to this point is that we can actually take the derivative of the derivative. So the derivative is going to give us a function, and we could find the derivative of that. And we call that f double prime of x. So that's just taking the derivative of the derivative, and we call that the second derivative. Well, now that we've done it once, there's nothing that would stop us from taking the derivative of the second derivative, and we put 3 little prime marks then, and that's called the third derivative. And we could take the derivative of that. Now we don't keep putting little hash marks. After about the third derivative, we use a 4 in little parentheses, and that would be the fourth derivative. And you could take the derivative of that, which would be the fifth derivative, and theoretically you could go on forever. So when it says find all the derivatives, what that is saying is take the derivative as long as you can. If it ever just becomes 0 over and over again, then you don't need to keep going. So here our f of x is x cubed plus 5x squared minus 5x plus 2. So our first derivative, right, would be 3x squared plus 10x minus 5. Our second derivative would be 6x plus 10, taking the derivative of that first derivative, right? 2 times 3 is 6, bring the power down 1, 10x, the derivative is 10. The third derivative here would be just 6. And the fourth derivative, derivative of a constant, is 0, and then the derivative of 0 is 0, and forever on it would be 0. So that's what we mean by higher order derivatives. If you're asked for the second derivative, you take the derivative, that would be the first derivative, take the derivative of again, and you would have the second derivative.